Flack math! Give me some math and I'll give you some flack. Flack math!
All right, here we go.
But I could like throw something at you and you would fall, and then I could jump you. I have a backpack I can
That's strong.
Not that hard. This is a light backpack.
Okay, what kind of graphs do you guys, can you guys think of? Graphs to represent data. You want me to give you one?
30% people like jelly beans, 70% of people like
Bar graph is one way.
30 people like jelly beans.
Okay, can you guys give me two other types of graphs?
Line graph.
A line graph. Okay, and we're gonna say, you can say line graph or a broken line graph, and we'll talk about what that means in a second. And then what's the third one?
I don't know.
Box graph.
So a line graph and bar graph look very similar. So if I had like my labels down here, January, February, March, April, May, and then I had some data over on the left here. Let's say this represents this car dealership and how many cars were sold in the months of January through May.
None.
Okay,
500.
number of cars sold. Okay, number of cars sold.
Dang, you're making fame.
473. So
Round up.
So let's say January they sold, the car dealership sold 50 cars. Where would you put 50 cars? Where would you put 50 cars?
Halfway in between the 100 and the bottom.
Yep, so let's do 50 cars. Color it in real nice.
50 cars?
Let's say February they sold 200 cars. You can go all the way up to
Why is it
200.
going up like 100 every time? What's it going down? 50.
Well, we can talk about the math later, since you need help with that, apparently.
Because more people.
That's what I'm in math class.
500
Bro,
the next one.
Bro, look at.
Let's say the next one's 150. They had a slower month, I guess.
Wait, it only goes up to 400, not 500.
And then April is
Can I guess the
350.
next one?
Oh man.
I think it's 350 for the next one. I'm right.
Attendance on two, attendance on two.
It doesn't look like.
Okay, and then May we had 100 cars sold.
Just maybe. I totally can't see that in my book right now.
Okay, so a line graph and a bar graph look very similar. The labels look pretty much identical.
They are identical.
No.
And the scale looks pretty similar too. 100, 200, 300, 400, 500. The number of cars sold.
It's just the
Okay,
same thing.
but instead of drawing a bar, you're just putting a dot. And going up to 200, and going down to 150, and then up to 350, and then down to 100. So it looks like this. So, have you guys ever, like, if you break a stick that's dead, like like you find a stick in the woods and it's been off the tree for months, what's going to happen when you break that stick? It's going to break into two pieces. We call that, what is it, compound fracture?
It might break into a bunch actually. 'cause
What's the fracture that it just kind of breaks but it doesn't separate?
Well, it still separates.
a crack.
Because if you break it in
So you break a newer branch, what's going to happen? The bark's going to still be still
crack.
alive, and it's just going to kind of break it like this. So this is why they call this a broken line graph. So it's kind of like we did 1, 2, 3 different breaks. Okay?
Oh.
That's why they call it a broken line graph. But it still represents the same data. And a broken line graph is kind of nice, even though you can probably figure it out by looking at this, but look at the increase between March and April. And then what happened between April and May? Because did we lose a really good employee that was good at selling cars? I don't know.
Yep.
But a line graph is nice because you can see it linearly, like what happens in the year. Oh, it looks like April is a good time to sell a car. Probably not a good time to buy a car, but a good time to sell a car. Good time to buy a car would probably be in January, because January, I don't know why January doesn't have, maybe it's right after Christmas and they're broke. People are broke. Do you need to sharpen that? Go for it. Yep.
I like the bar graph better.
Okay, there's a third type of graph. Can you think of it yet?
No graph.
Real graph. Circle graph.
Pie graph or circle graph, it means the same thing. Now, a pie graph, what does a pie graph look like?
But there'd be a bunch of different sizes of slices.
There is.
Yeah, and usually it's kind of like percentages, right? So if you had something like this,
That guy was in that.
What? Look at that.
Smoking.
Wow.
It feels really weird.
Bro, that just seems weird.
okay, so it could look something like this, where this looks like it could be maybe, I don't know. Looks like a little bit more than a fourth of a pizza, so maybe 30%. Could be
30 degrees or 30%.
30%
Nobody cares.
on what could this be? This could be like your budget. So maybe you're like food. This is your budget. And then you got like, what does that look like? Maybe a 12% would be on water bill or something, or electrical. What is this? Looks like about 30%, not 30%. Oh, that is. %, maybe 15% on gas. Let's do 14% on water bill. Let's stop clicking that pen. And then let's do 13% would be what? Internet.
Yeah.
10%. What are we up to? What should this all add up to?
100%.
Should add up to 100%. Let's see what we got so far. So we got 30 plus 30 is 60, 70, 84. So this is 16%, which doesn't look right, but that's okay. This is like, let's say music, streaming services or something.
No way.
What else do we got? Entertainment.
That's a lot of money for music.
Entertainment.
That's an expensive spot. That's expensive Spotify, man.
Okay, so a pie graph is nice when you are trying to figure out how much of the whole thing there are. So a pie graph, maybe you can make a pie graph out of the year, like the whole year of selling cars. Which month, which is the biggest slice of pie? It looks like April.
Yeah.
You could do the same thing here, break this up into, figure out how many total cars sold, right? And then do the math and figure out the pie slices and how much of those slices would be. Okay? So this is 3 examples. Okay? So you would use a pie graph ideally when you're talking about parts of a whole. Okay, and you can do that with your car sales or whatever, depending on what you want to do with the data. Like if you just want to know which ones had the best, which months were the best, or if you wanted to see as it compared to others, it's nice to have a pie graph. Okay. All right. Do you guys have questions on graphs?
Nope.
So this is going to be in your homework because it might be on a test or two coming up.
We never
You have to
homework.
be able to build a graph and read a graph. You guys think you can do that?
Yeah.
More.
Okay.
I've made so many.
Let's move on to lesson 30.
That was only 29?
That was so short though. That was like 10 minutes.
We're supposed to leave already.
I'm supposed to leave right now? Why?
So we can eat.
Probably. No, we gotta be.
Talking about.
His brother, you supposed to leave like right now because
It's his birthday.
today.
But my mom was like, oh, you're gonna go all the way through school now.
Bruh.
Probably couldn't.
Okay. All right. Now, this is where fractions could potentially get a little confusing. I think most of you are pretty decent, have a good, decent knowledge of fractions. Okay, but this is where you really need to make sure you're on the same page, because this is where fractions get confusing, is when you try to add fractions with different denominators. So we're going to add and we're going to subtract fractions with different denominators.
Why did I have to write on it?
Okay, but first things first, let's Rochambeau
Rock, paper,
to
scissors.
see who's going to sit over there.
Me.
Okay, so
You do on mine.
Daniel, you go against Mark.
Oh. Why
Rochambeau,
can't I get to you?
rock, paper, scissors.
I'm gonna do paper.
How about they both go to different tables?
Paper.
Okay, so Daniel won. So now you, Mark.
Paper, scissors, shoot. Bro, I said I was gonna do paper. Paper, scissors, shoot.
Shoot.
Okay,
Yeah.
so now Daniel, you are gonna go against Henry.
Wait, no. I'm gonna go paper. Paper. Oh,
Wait, rock.
paper, scissors, shoot. Yes.
Okay, so Daniel, that means you're going over to that table.
I'm so sad.
You don't let go? Bro,
Okay,
bro, I-
lesson 30,
Give it
adding,
back, Mike.
subtracting. So remember, let's go back to the different parts of a fraction. We've got the numerator, right? Numerator's on top. The denominator's on the bottom.
I need help.
Okay, so the denominator is your total number of parts or pieces, right? Total number of parts or pieces. So if you ate 3/8 of a pizza, that means you ate 3 out of the 8 pieces, okay? 3 out of the 8 parts. So this is your numerator is your number selected. This is how many you're selected. If you're talking about 3/8, you're talking about you're selecting 3 out of the 8. Now, what you're selecting for, I don't know. If you talk about you're eating 3/8 of the pizza, then that's how many you ate out of the 8. If you say 3/8 remained, that means 3 remained out of the 8 total. Okay? All right? Can you guys separate a little bit so you're not messing with each other? Okay, so if you got 1 out of 5 plus 2 out of 5, if you ate 1 out of the 5 pieces and then 2 out of the 5 pieces, how many total out of the 5 pieces did you eat? Henry? Yeah, 3 out of the
That was
5.
0.
So, if you have the same denominator, you keep the same denominator, right? So you add numerators and keep the same denominator. That's how you add fractions that have the same denominator, okay? It makes sense. If you ate 1 out of the 5 pieces of banana bread, and then you ate 2 out of the 5 pieces of banana bread, okay, here's your banana bread.
Thanks.
you ate 1, it's gone, right? And then you ate 2 more, then that is 3 out of 5, right? 3/5, yes.
Can we go to the bathroom?
Yep.
Yeah.
Okay, but what happens if you have fractions? Now you could do this pizza-wise. What happens when you eat 1/4 plus 1/2 of the pizza?
You have to
3/4.
2 or yeah.
Yeah, you get 3/4, but let's look at it this way.
2.
You got 1/4. You got 1/2 plus 1/4. So you got this whole thing plus 1/4, and you can tell by just looking at the pizza that that's 3/4 of the pizza. Or if you think about it, money, half of $1 plus a quarter, half of $1 is 50 cents plus a quarter, 75 cents. 75 cents is 3/4 or 3/4 of $1. But what you could have done is you could have cut this 1/2 into some pieces. Look what happens. So really what you're doing is you, instead of 1 out of 2 pieces, it's 2 out of 4. Well, what you did there, when you cut it in half, you cut the number of selected pieces in half, and you also, you cut the number of selected pieces in half, and you cut the total number out of what it's out of. So you doubled the number of pieces selected, and you also doubled the number of total pieces. So what's happening is you take this 1/2 here, and you double the top and you double the bottom to get 2/4. So 1/4 plus 2/4 equals 3/4.
Yay!
So the goal is to cut your pieces so you have the same amount of pieces total. Now, you don't have to think about pizza, you don't have to think about banana bread to be able to add these fractions. You just have to make that bottom number the same. So you can do whatever you want to one or both of the fractions to make that bottom number the same. That's your first goal, and really your toughest thing about adding fractions is that. If you can figure out how to add fractions, you can do anything with fractions, okay? Now, if fractions scare you, if fractions confuse you, then this is the only thing, this is the most difficult thing that you're gonna have to learn ever about fractions, okay? So today is a very important day. Let's make sure you guys understand fractions before we move on. All right, so let's forget about the pizza and the banana bread for a second. If our goal is to get the same bottom number, then let's see if we can do that, okay? Now, here's the only rules. With getting the bottom number, the only rule is you can only use multiplication, all right? So let's try something. Let's try 3/5 plus 7/8. Okay, 3/5 plus 7/8.
Are we doing this?
Let's do something else. Let's do 3/4.
Can you give us a problem we can get some points for his problem set on?
I will eventually. 3/4 plus 7/8. Now, what can you do? You can only use multiplication. What can you do to make these denominators the same?
Double the 4.
Yeah, all you have to do is double the 4. So this just has to multiply by 2, and here's the golden rule. Whatever you do to the bottom, you have to do to the top. And then your fractions are the same. So it's kind of like that pizza where you're cutting everything in half. So you're doubling everything. So this is 6/8 plus 7/8. What's your final answer, Jordan?
1 5/8.
Yep, or 13/8, which is equal to 1 5/8 if you change it back to a mixed number. Okay? Now this was nice because all we had to do is change one of the bottom numbers, right? To make it look the same. Sometimes you have to change both. So let's do this problem. 3/5 plus 7/8. Okay, now you can't multiply by 5 by anything. Guys, sit on opposite sides of the table. There you go. Okay, you can't multiply by 5. 5 doesn't go into 8. I mean, you could multiply it by 1 and what? 3/5. If you multiply it by that, then it'll equal 8, but you don't want to do that, right? That'll be a really confusing fraction. But you can multiply both by something. So you have to decide what can you multiply by 5 and what can you multiply by 8 so they end up with the same denominator.
40.
What do they both go into? 40 is a good guess.
You're a genius, Henry.
And that's where you can always start. You can always start by just multiplying them together. 40. Now, is there a smaller number that they both go into?
40. No.
No, it's just 40. So what do you have to multiply 5 by?
8.
8. What do you have to multiply the bottom by? Or this over here by?
Can't you get just times the denominator by both denominators?
You can, and that will give you a common denominator. It won't give you the least common denominator all the time. You could have done the same thing over here, Jordan. You could have multiplied these two together to get 32.
That wouldn't be the same denominator.
It would have been.
Well, I mean the common.
You would have had 24 30-seconds plus 21 30-seconds.
Waste of time.
You would have had 55 30-seconds, and then you can or whatever. I don't think I did that right. 55 30-seconds. I don't think so. It would have been 42 30-seconds. 42 30-seconds. So if you get that, then you can reduce it, and you would still get 13/8. Okay. So this is 35 40ths, and then you can add them together, right? 59 40ths. You're done. You can leave it improper if you want. All right. So let's write out the steps. If you guys like to have steps, then let's write the steps. So here's the steps to adding fractions with different denominators. Step 1. Find LCD. What does LCD stand for?
Least common denominator.
Right. And not liquid crystal display, I think is what the LCD TV.
But that's like
Least common denominator. What do both denominators go into?
Lung cancer death.
Wow, that's morbid.
What do both even
I didn't even hear it. Say it again.
Lung
Denoms.
cancer death.
Wow.
What do both denominators go into? Okay, find the least common
Beautiful. I like
denominator.
that.
Step 2, rewrite all fractions with new denominator. Okay? Well, after you figure out what they both go into, you're going to do that. So like over here, when we had 3/5 and 7/8, so this was our next step. Right? That was step 2. And then step 3 is find new numerators. Well, how do you find the new numerators? This is the hardest step in all of this. Step 3. Well, how do you find the new numerators?
Do what you did to the bottom to the top.
Yes. So multiply old numerator. Multiply old numerator by what you multiplied the old denominator by. By what you multiplied old denominator by. To get LCD. Okay? This is the golden rule. What's the golden rule in life?
Don't die.
There's a better one than that.
What?
What's the golden rule?
Don't go on monkey.
What did your parents tell you? What's the golden rule?
Don't trust anyone.
No. My parents told me to trust
Never go
people.
outside.
Never go.
I doubt your
Ah, yes,
Never
yes,
shower.
yeah,
Oh my gosh.
Only use
I
Discord.
guess it's a
No
different
food in your
time
bedroom.
Be a Discord.
after
I
COVID.
eat so much
Lots
in
of
my bedroom.
parenting
Dude,
techniques have
Don't
changed.
trust
I
anyone.
had pizza bombs in my bed.
Treat others the way you want to be
Discord
treated.
moderate.
Shh. Do unto others as you would have them do unto you. Treat others the way you want to be treated. That's the golden rule.
Don't trust
So
people.
treat the numerator how you treat the denominator. So whatever you multiply by the numerator, multiply by the denominator. Okay? Whatever you do to the bottom, do to the top. Whatever you do to the top, do to the bottom. Okay? Treat it the same. Number 4, add or subtract. Numerators, and then keep the same denominator. That's it. My handwriting has gotten worse over the years.
We can read it. Ours is also bad.
Keep the same denoms. Okay? All right.
Not that guy, Mark.
Bro.
Let's do a few examples. Ready? Do you guys want some Flack attack points?
Yes!
No.
I need
No. We do
Can I
not
go
want
get
any.
water?
No, we're gonna wait.
Hey, that's the Flack attack points. I'm using them up every week.
Bro, how are you already low? Not like we started out at 0.
5/11ths minus 1/5. Ready, go. When you got it, show me.
Hey, over here.
Hey, you, over here.
Guys,
No.
what's the question again? Hey, what's the question again?
Hey! We're not past the first semester.
My mom was just like, oh, you might be able to use a
I'm
calculator
done.
class.
And you're not even started.
That's what my calculator was for.
Wait, it doesn't matter if we do it. He gets it.
Well, I'll still give you.
I might have been wrong. I could have been wrong.
David, I'm
Who doesn't
drawing
want
you.
some Flack attack points?
I don't know how to do them on this.
You know.
I'm drawing David.
I think I've got it.
Okay. Good job.
Is this not erased?
Well, you still get points for trying, for getting it right. You guys get it? Oh, I think you might have added. Well, where's your step? Oh, I think you multiplied this by the wrong. So whatever you do to the bottom, do the top. So you multiply this by 5. So you have to multiply the top by 5. So instead of 55, it would be 25. And then you multiply this by 11. So you multiply the top by 11. It would be 25 plus 11. What'd you get?
0.
All right.
Over
You guys still
55.
working?
No.
I see you working, Henry.
I'm drawing you, David.
I need points because I use like my Flack attack every week. I don't like to.
Every week?
Every week?
You aren't earning them that fast, are you?
No. If I have them, I'll try to use them.
Okay,
No.
let's try this.
I went
So,
through all of the last like weeks
uh,
of school.
do you want to walk me through this?
Alright, David.
No, not at all. Chloe, what did you do? Okay, here's another good suggestion. This is a good Flack hack, right? Here's a good Flack hack. Step 0. Rewrite the problem vertically.
Oh, I never even think of that.
Okay? Here's why this is easier. Because then you can find your common denominator. What's your common denominator with 11 and 5? What do they both go into?
55.
55. When all else fails, you multiply them together. So they both go into 55. So here's the first step. Now this is why it's nice to write them vertically, because look what I can do. I can say, okay, what times 11 equals 55? Well, 5. Okay, so times 5 times 5. See how I'm multiplying the bottom and the top by the same thing? So this gives me 25. And then what do you multiply 11 by to get 55?
5.
Or 5? You multiply it by 11. So 1 times 11 times 11 times 11. See how that easy that works? So if you write it vertically,
How did you get that?
you can see all your math there.
Oh.
How-
Wait a minute.
Okay, and then now that we have our new numerators, step 4 says add or subtract. Don't forget this is subtraction.
doing multiplying yet? Wait, no. We already did that.
I think this is still going. 1 second. I gotta flip this.
Gordon, you're gonna get it.
Yeah, that's my hope.
Not my problem.
Well, I hope so.
Why? That just makes it harder to read and stuff. You're not gonna die for that.
Okay, so once you get there, then subtract 14 55ths.
Bro, I'm not gonna die from a concussion.
How's that feel?
Great.
Okay, let's do another one. You ready?
Sir.
Let's get a little crazy here. Let's do 1/4.
Already in the
And I'm gonna skip step 0 and go right to step 1. So I'm gonna write them vertically at first. 5/9 and 2/3.
Oh, we're adding.
Okay?
I think he's right.
So now, don't say it out loud, but let's write this number down first. What do all 3 of these denominators go into? So write it down on your paper so I can see it. If you don't do any of the other problems,
question.
I mean, part of it, that's fine. I just want to see.
If what 1/4, 5/9, and 2.
No. What all 3 of the denominators go into. What do all 3 of the denominators go into? See if you can tell me what that is. Way too sciencey.
He said he was going
I
at
said not to say it out.
Oh! Oops.
I need to hear that.
I'm sorry.
Write it down on your paper. Show me
This?
you're not. Show me you're paying attention.
You didn't.
Yeah?
How did you get that?
Yep. Figure it out.
Bro, you just said
Remember
yeah.
they all go into.
No. I shouldn't have.
So what number? What can you change all those 3 numbers to so they're the same? So what can you multiply
Wait,
by?
no. Wait,
All the
no.
numbers.
It's fine, I
You can
don't
multiply them by different numbers,
I
but
can't do.
what do they all go into?
My
What's their
fingers.
least common multiple? You remember talking about that? Least common multiple? So here's where my mind goes. So 3 goes into 9, so 3 is going to go into everything that 9 goes into, right? So now I'm going to ignore 3. So I'm just looking at 9 and 4. What do both 9 and 4 go into? We'll start listing 9, 18. 4 doesn't go into 18. 27, 36. It goes in 4 times. So when all else fails, remember, just multiply them by each other. So they all go into 36. So that's what I'm going to write. This is step 2. I'm writing each fraction with the new denominator. Now I'm going to do the math. The math is going to be different for each 3 problems. So, Chloe, how do you figure out this numerator? Okay, what's that magic question? What's the golden rule?
Treat the top by
Yep. So how did you treat the 4? How did you turn that 4 into a 36? What'd you do?
times it by 9.
Yep. Times 9 times 9. So then you just do that math. What's 1 times 9?
9.
9. All right. LeBlanc, what did you do to that 9 to make it a 36?
Multiplied it by 4.
Or times it by 4? 5 times 4, 20. See how we're doing the same thing to the top as we are to the bottom? All right, one more. Okay, this is not something you did consciously, but you still have to figure out what times 3 is 36?
12.
18.
18.
12. So 2 times 12
Ready?
is 24. Now we can add them all together. 29 plus 24 is 33 over 36. And then you could reduce that. Do you know what goes into both 33 and 36?
3.
3.
3. You can take a 3 out. Did I not do this right? I didn't. Yeah, I didn't do that. That's 5336.
Oh, I
Oh,
really thought I
embarrassing.
got it wrong there.
5336. And you can leave it like that. There's nothing that goes into both 53 and 36, or you could change it to a mixed number. Can you do that in your head? 36 is only going to go into
1 over
53 one time, but how many is left over? We'll just subtract it. What is that, 17?
1430. Oh, wait, no. I got 14 somehow. I might have messed something up.
Okay, so either of these answers are right, just make sure it's reduced. Changing to mixed number does not mean reduce.
Do we get positive outputs?
Did you guys get this right? I guess I didn't even look to see if you got it right.
Good check, right?
Sorry.
Oh, yeah. He just told us how to do it.
Well, you guys told me how to do it, but we did it all together. Okay, that's it. Lesson 30. I'm going to give you all Flack Attack points for that one.
Black man.